bisector of a segment or is a line, segment, or ray, it could be any of those three, that's perpendicular to a segment at its midpoint. That's the key part for bisecting. It's at the midpoint. It cuts the segment in half. Now, there's just one per segment in a plane. So you should not have several perpendicular bisectors. There's only one in a segment in a plane. So we're given AB, and we want to construct line XY, so it's perpendicular bisector to AB. So you have your AB here, and step 1 says to put the compass on point A. So we're going to take our compass, put the point on A, draw a long arc. Now we're going to draw a long arc by making sure our compass is a little bit past halfway of the segment. If it's halfway, it'll be too short. So make sure it's a little bit past halfway. Make a big arc. Now you're going to pick up your compass, and you're going to now take the point and put it on B. And you're going to do the same thing. You're going to make an arc. Now, depending on how big that you stretch it out, depending on how big you need to make your arc. But you want to make sure they overlap. Now let's label the top X and the bottom Y. And what we'll do is, you notice that they intersect. The two arcs that we drew cross. So where they cross, it forms 2 points, which we labeled X and we labeled Y. So now we're going to take our straight edge and we're going to draw a line through those 2 points. And make sure you put arrows because we're talking about a line here. And there is our perpendicular bisector. Now remember, a bisector is going through the midpoint. And so we're here, where it touches AB is the midpoint, and we're going to label that M. And we can put in a 90-degree angle to show it's perpendicular. Alright, let's draw ST and construct a perpendicular bisector of our own. So, any line that you want, ST, there's mine, S and T. And I want to construct a perpendicular bisector. So first step again, take your endpoint, put it on S. Stretch out your compass so it's a little bit past halfway of your segment. Then make a big arc. Pick up your compass, don't change it. Take your endpoint, put it on T, make another big arc. Make sure the arcs cross. Then you're going to take your straight edge, and then where they cross, those 2 points that they cross at, you're going to draw in a line. Mine's a little bit off. And there is your perpendicular bisector. Alright, now let's look at an angle bisector. It's a ray that divides an angle into 2 congruent parts. So it divides an angle into 2 congruent angles. Its endpoint is at the angle vertex. And within the ray, a segment with the same endpoint is also an angle bisector. So let's look at an example that uses it. We have angle JKL, and KN is our bisector. And it says angle JKN. So here's J to K to N. That angle right there, it says is 5x minus 25. So let's put 5x minus 25. And then it says that angle NKL is 3x plus 5. So we start here at N, go down to K, go over to L. That angle is 3x plus 5. So I put that right in there. Now, have you noticed the angles have been marked with these little red marks here? Because that means that they are congruent, because it's an angle bisector. So what I just said was that angle JKN is congruent to angle NKL. We can use that to be able to solve for x and to find JKN, angle JKN. So let's start. We said that they were congruent, or they equaled. So let's substitute what they were in form. So angle JKN was 5x minus 25. And angle NKL was 3x plus 5. From there, we can solve for x. So we're going to first add 25 to both sides. And we get 5x equals 3x plus 30. Now we want to subtract 3x to both sides. So subtract 3x, and you get 2x equals 30. Now we're going to get rid of the 2 by dividing to both sides. And we have solved for x and get x to equal 15. Now we were asked to find angle JKN. And if you look up here at the top, angle JKN was 5x minus 25. So it's equal to 5x minus 25. So what we can do is substitute 15 for x. So we're going to substitute 5 times 15 minus 25. And when we solve that out, we get the measure of angle JKN to equal 50. And we solve the problem. Now, there's 2 more that it's asking for. It's asked us to find angle NKL and the measure of angle JKL. Well, if you remember at the beginning, we said the measure of angle JKN was equal to the measure of angle NKL. So if JKN is 50, then so is the measure of angle NKL. So first one, easily done. What about measure of angle JKL? Well, the measure of angle JKL is the whole angle. So that means you just add up the 2 parts. Add up both angles. So if you add up both angles, you get that the measure of angle JKL is equal to the measure of angle JKN plus the measure of angle NKL, which is 50 plus 50, which is 100. Okay, moving on. We're looking at angle A, and we want to construct AX, ray AX, that's an angle bisector of angle A. So the first step that we want to do is we want to put the compass, the endpoint, on the vertex of angle A. And we're going to stretch it out however far you want to and make an arc. And where that arc touches, we're going to label the top point B, and we're going to label the bottom point C. Alright, now step 2, we want to take our compass and we want to put it on point C and draw an arc on B so we see how far that is. I'm sorry, take a step back. We want to take it on C and we want to put it out a little bit past halfway and draw an arc. And then we're going to take the same measurement of that compass but put it the endpoint on B and draw another arc. And where they cross, we're going to label X. So step through that one more time, make sure everybody got it. We took our endpoint, put it on C, and we made sure we stretched it out a little bit past halfway, and we made an arc here. Then we took the compass without changing it, put the endpoint up here on B, and made another arc, and we labeled that X. Now, where they cross at point X, is our ray for our angle bisector. So what I do is I start here at the vertex of A and draw a line through X. And there's our angle bisector. Cuts that angle A in half. Okay, so let's draw an obtuse angle, angle XYZ, and let's construct its bisector, YP. And then we'll explain how we use the protractor to do it. So first, we want to construct an obtuse angle. So that means greater than 90. So there's my angle. We're going to label it XYZ. So up here will be X, vertex Y, and down here is Z. Now we want to construct the angle bisector of that. So the first thing that I want to do is I want to label first my points of where X and Z are. And then I'm going to take my protractor, take the point, put it on Z, and make a mark, an angle. Remember, make sure it's a little bit past halfway. And then I'm going to take X and I'm going to do the same thing, make another mark. And let's label that point that we made, where those two crossed, let's label that C. And then we're going to take our straight edge and we're going to start at Y, and we're going to put our straight edge down, and we're going to draw a line from Y over to C. And there's our angle bisector. Now, to explain how we used our protractor to check our construction, what you can do is, I'll write it out here, you can measure angle XYP and angle PYZ to see that they are congruent. Because if it's an angle bisector, it should be congruent. Therefore, you take your protractor, again, the center part of where it's 0, you should put right here on Y, and then follow along the protractor, see what this degree is, and then do the same thing from the other side, because there's two lines to the protractor to read, and see if from here to there is the same thing or not. Okay. That's it for today. Thank you, and come again.